So, good afternoon to everyone. Welcome back to today's class again. So, today's topic is the oxidation number. So, in this class, we will going to study about the how to calculate the oxidation number. So, today's topic is oxidation number. So, today we are going to study about the how to calculate the oxidation number of element or compound. So there are the different rules. There are different rules are assigned to calculate the oxidation number. So we will see this rule one by one, and after that we are going to solve some questions to understand this concept. So first we are going to discuss about the rules. First rule. First rule is that the oxidation number of uncombined or free element is always 0. First rule, oxidation number of uncombined or free elements is 0. The oxidation number of uncombined or free elements is 0. Those elements are in a free state or uncombined state. They have the oxidation number is 0. For example, free state of sodium is oxidation number is 0. Uncombined state of calcium is oxidation number is 0. The first rule, oxidation number of uncombined or free element is 0. Second rule, the oxidation number of polyatomic compound or polyatomic ions is always 0. Oxidation number of polyatomic ions is 0. The oxidation number of polyatomic ion is 0. Second rule is the oxidation number of polyatomic ion is 0. Third rule is the oxidation number of monatomic ion is same as the charge present on it. Oxidation number of monatomic ions same as charge present on it. Third rule, the oxidation number of monatomic ion is same as the charge present on it. For example, like sodium Na plus. So oxidation number of Na plus is +1. Like calcium having the +2 charge, so oxidation number of calcium is +2. This third rule, the oxidation number of monatomic ion is the same as the charge present on it. For example, sodium having the +1 charge, so monatomic ion of sodium is oxidation number is +1. Monatomic ions of calcium having the oxidation number is +2. This is about the third rule. Now fourth rule, the oxidation number of oxygens having the 3 different states, or oxidation of oxygen having the 3 or 4 different numbers. First, oxidation number of oxidation number of oxygen, the oxidation number of oxygen having the different numbers. First, generally oxidation number of oxygen is ±2. Oxidation number of oxygen is in general is -2, but in peroxide like H2O2, it is minus 1. The oxidation number of oxygen is always minus 2, but except in peroxide like H2O2, it is minus 2. Second, the oxidation number of oxygen is plus 2. The oxidation number of oxygen is plus 2 when oxygen is bonded with the more electronegative atom like O2F. When oxygen is bonded with the more electronegative atom, its having the oxidation number is plus 2. For example, O2F. And third one is the oxidation number of oxygen is plus 1 when oxygen is bonded with the O2F2. So oxygen having the 4 different oxidation numbers. First is minus 2 when in general is minus 2, and minus 1 in the case of peroxide, plus 2 in the case of oxygen is bonded with the more electronegative atom like O2F, and fourth one is plus 1 is when oxygen is bonded with the O2F2. These are the 4 different oxidation numbers of the oxygen. Now we will see next. The oxidation number of hydrogen is plus 1. Fourth one, the oxidation number of hydrogen. The oxidation number of hydrogen is plus 1. In generally, the oxidation number of hydrogen is plus 1, but except it is minus 1. It is minus 1 in the form of the hydride. For example, in the form of hydride like lithium hydride, sodium hydride. The oxidation number of hydrogen is always plus 1, but in a hydride like sodium hydride, lithium hydride, it is a generally metal hydride, so it is a minus 1. So next one is 6.1. The oxidation number of halogens. Oxidation number of halogens is minus 1. The oxidation number of halogen is always minus 1. Halogens means chlorine, bromine, fluorine, iodine. Next one, 7. Oxidation number of group first element. Group first element is plus 1. The oxidation number of group first element is plus 1, and group 2 element is plus 2. The oxidation number of group first element is plus 1 and group 2 element is plus 2. These are some basic rules to determine the oxidation number. Now we will solve some questions to understand this concept. First question, calculate the oxidation number of phosphorus in H4P2O5. Calculate the oxidation number of phosphorus in H4P2O5. Calculate the oxidation number of phosphorus in H4P2O5. First step, we have to give the value. We have to recall the rules. First, we will consider the oxidation number of hydrogen is plus 1. Then we will consider the oxidation number of phosphorus is X, because we have to calculate this phosphorus oxidation number, and oxidation number of oxygen is -2 is as always. So let's consider oxidation number of phosphorus is X, because we have to calculate the oxidation number of phosphorus. That's why we consider it is X. Oxidation number of hydrogen is +1 according to a rule, and the oxidation number of oxygen is -2 according to rule. So we get the some values. Put this value into this equation. Like here is the 4 hydrogen, that's why we write the 4 into 1, because 1 is the oxidation number of hydrogen, plus 2x because here is the 2 phosphorus, plus 5 because here is the 5 moles of the oxygen, into -2 is equal to 0. All the values are given in the equation, and let's solve this equation. 4 plus 2x in bracket -2 is equal to 0. 2x is equal to 10 minus 4, 6. 2x is equal to 6. So x is equal to 2 divided by 6. So x is equal to 3. X is equal to 3. So oxidation number of phosphorus in the H4PO2O5 is +3O3. Understand? Let's solve another example. Calculate the oxidation number of iodine. Calculate the oxidation number of iodine in H4iO6 minus. Calculate the oxidation number of iodine in H4iO6 minus. Now again recall the rule. Let's consider oxidation number of iodine is X, and the oxidation number of hydrogen is +1 according to the rules, and oxidation number of oxygen is -2 according to the rule. And put this value into this formula and solve. 4 into 1 plus x 6 into -2 is equal to -1. -1 we wrote here because here is overall charge is -1. Solve this equation. 4 plus x minus 12 is equal to -1. Then we will solve this equation. 4 minus 12, 6 into 12. Yes, 4 x plus 12 minus 1 is 12. First we have to x is equal to 12 minus 4 is equal to -1. X is equal to 8 is equal to -1. So x is equal to 8 minus 1. X is equal to 7. Let again revise this. First take the values like oxidation number of hydrogen is +1, oxidation number of oxygen is -2, and put this value. 4 into 1 x plus 6 into -2 is equal to 1. So 4 into x, 6 into 2 is 12 minus 12 is equal to -1. X is equal to 12 minus 4 is 8, and then -1 is charge, and x is equal to 8 minus 1 is x is equal to 7. third question. Next question. Question number third. Find the oxidation number of chromium in sodium dichromate. Find the oxidation number of chromium in sodium dichromate. Na2Cr2O7. Consider consider the oxidation number of chromium is X and the oxidation number of sodium is 1 and oxidation number of oxygen is -2. So let's consider oxidation number of chromium is X and the oxidation number of sodium is +1 and the oxidation number of oxygen is -2. And fill this value in this formula to solve the equation. 2 into +1 plus 2x plus 7 into -2 is equal to 0. Then 2 into 1 2 plus 2x plus -14 is equal to 0. 2x is equal to 14 minus 2. 2x is equal to 12. X is equal to 2 divided by 12 is x is equal to 6. Solve this equation, you will get the answer x is equal to 6. Last question, question number 4. Find the oxidation number of nitrogen. Find the oxidation number of nitrogen in NH4NO3 ammonium nitrate. So we have to divide this equation into two parts, NH4 and NO3. So we will get the two different oxidation number. So first we will solve about the ammonia. So oxidation number of nitrogen is in ammonia NH4. Consider the oxidation number of nitrogen is X plus oxidation number of hydrogen is +1. So that's why +1 is equal to 0. Let's solve this equation. X plus 4 is equal to 0. Here is -1 +1 charge. NH4 plus 2. So +1. So x is equal to 4 into 1. X is equal to 3. Oxidation number of nitrogen is X. That's why we consider here X. And the oxidation number of hydrogen is +1. And here is the +1 charge. That's why we wrote here 1. X plus 4 is equal to 1. X is equal to 4 minus 1 is equal to 3. So oxidation number of nitrogen in ammonia is +3. And in nitrogen in nitrate. So X is the oxidation number of nitrogen. Then 3 into -2 is equal to 1. Here is also 1 charge. So x is equal to plus -6 is equal to 1. X is equal to 6 minus 1. X is equal to 5. So oxidation number of nitrogen in ammonium nitrate is +3 and +5. There are the two different oxidation numbers of nitrogen in ammonium nitrate. Thank you.